Well, today we are doing the present value formula. So this formula is on your formula page and it looks something like this. So look at your formula page and you copy this exactly like it is. So when do we use the present value formula? So normally we use the present value formula when we are either we're making regular payments or we are making regular withdrawals. So if you make regular payments, normally this is for a loan. So normally you take out a loan and now you must pay off the loan by making regular payments. Or you win the lotto and you put the money in the bank and you decide you want to make regular withdrawals from the money that you won. Or you inherit money and you put that in the bank and you make regular withdrawals every month. So that's when you would use the P formula. So just make sure you understand that. Most of your examples will be on loans. And here and there, you will see these two examples. So another important thing that you must remember is that if you make monthly payments, so let's say you make monthly payments, then this gap over here must be 1 month. So before you make your first payment on your loan, there must be a gap of 1 month. So you must always start 1 month after you take out the loan. Let's say you make quarterly payments, then this gap over here must be 1 quarter or 3 months, okay? So 1 quarter is 3 months. So if you take out a loan and you make quarterly payments, your first payment is 3 months after you take out the loan. If you make semi-annual payments, then this gap over here must be 6 months. So let's say you make half-yearly payment, then the question must say, your first payment is 6 months after you took out the loan. And if you make annual payments, because that's also a regular payment, then this gap over here is 1 year after you take out the loan. Whenever this is the case, you just substitute into the P formula. So let's look at our formula now. So this P over here refers to the value of the loan, okay? So if you are buying a car for 500,000, the value of the loan is 500,000. It is not the money that you are paying back. You will always pay back more than the loan, eh? X is the regular payment or the regular withdrawal. I is the interest rate over the compounding period. And N is the number of payments. Okay, we've done that before. So let's look at the example. It says, Mpo can afford to pay back at most 8,000 Rand per month on a car loan. So that will be his monthly payment. And this is a loan. The interest on a car loan is 15% per annum compounded monthly. He will make his first payment 1 month from now. That's normally, if you make a monthly payment, you must start 1 month from now. That's normal. Okay, and he will pay back the loan over a period of 5 years. And here's the question. What is the price of the most expensive car that Mpo can afford? So what is the value of the loan that he can take out based on the information that they gave you? Okay, so first thing, you ask yourself the first question. Am I using the F formula or the P formula? I am using the P formula because I am making regular payments and this is for a loan. So I'm going to write my formula down. So P is the value of the loan. I don't know what the value of the loan can be. X is the monthly payment. And if I look at my question, X is this 8,000 Rand per month. So I'm going to make my X 8,000. My I is my interest. Let's go look. It says 15% per annum, compounded monthly. So I'm going to write 15% is 15 over 100. This is 0,15 compounded monthly. And N is the number of payments. So let's do a timeline. I do T0, that's now. I never pay now with a loan, eh? So this is my first payment. There is my first 8,000. Then my second month, there's my second 8,000. And then to get to this last one, I'm going to say 5 years. Monthly payments is 60. So this is 60. So from T1 to T60 is 60 payments. So this is just 60 payments. And now I go substitute all of this into my formula. Eh? So I'm going to write my formula again, but now I'm substituting. I don't know what P is. This X is 8,000, so 8,000. Then this I, the interest, is this over here. So I put that in. Then this minus N over there is the number of payments. So it's a negative 68. And then over the interest. So over the interest, which is this. And then I put all of this in my calculator to get the value of the loan. So all of this, I punch in my calculator, and you should get an answer of 336,276,73. And this is the value of the most expensive car that Mpo can afford. And there you worked out the value of the loan. So the value of the loan will be this amount. Okay, let's look at our next example. It says, Jenny wishes to repay a loan of 150,000. So that is the value of the loan by means of 16 equal quarterly payments. So they give you the number of payments, eh? You're going to make 16 payments. And it says you are starting 3 months from now. Is that normal? Let's quickly check. If I make quarterly payments, I'm supposed to start 3 months from now. Yes, that is normal. Furthermore, it says the interest rate on the loan is 21.5% per annum, compounded quarterly. Okay, that's good. First question. Calculate Jenny's quarterly payment. Okay, so what will Jenny's quarterly payment be? The quarterly payment is the regular payment, so we have to solve for X in this question. Okay, let's do that. First, she is making regular payments, so we need to figure out, is it P or is it F? Now, in this case, it's P because we are working with a loan. So first things first, let's write our formula down. So from your formula page, you don't memorize, you write your formula down. Okay, I wrote my formula down. So P, let's quickly write here, is the value of the loan. P is 150,000. X is the regular payment. Oh, no, I don't know what that is. N is the number of payments. They tell us it's 16. And our interest is 21.5 over 100 as a decimal. This is 0.215 compounded quarterly. So over 4. Okay, so let's substitute this in. P is 150,000. I don't know what X is. Then, let's see, this is the interest, compounded quarterly, and this is to the negative 16. So it's not 16 times 4, it's just 16 number of payments, and this is over the same interest. So that is the same interest, but now I'm solving for X, eh? So to solve for X, do you remember grade 12? First, I take this over, so I'm going to multiply by that. So let's write that down. Okay, so I wrote that down. Then I want X by itself. To get X by itself, I need to remove this whole bracket over here. If I'm multiplying on top, I'm going to divide at the bottom. So I'm going to bring that whole bracket down and put it here at the bottom. So that whole bracket will go here now, eh? And this is now all equal to X. And now I can put all of this in my calculator and work out the value of X. Okay, and I get my X to be 14,212.35 cents. Let's go on. Question number B says, calculate the total interest that Jenny will pay on the loan. Okay, so to get the amount of interest, so they don't want the interest rate, eh? They want the amount of interest that Jenny is going to pay. So to work out your interest, you're first going to work out your total repayments. So I'm going to say, okay, what am I actually paying the bank? And then I'm going to say that minus the value of the loan. Okay, so that's how you get your interest. Now, do you see this total repayments? Total repayments is the regular payment that you are making times the number of payments. So let's work that out. Our regular payment is this amount over here. We are making quarterly payments. And how many of them are we making? We are making 16 of them. So our total repayments that we're paying the bank will add up to 227,397 and comma 60. So that's how much money we pay the bank. So now I'm going to say my total repayments minus the value of the loan. Remember, the loan was 450,000. So when you buy the car for 150,000, but you're actually paying this back, eh? So that means the difference between these two things is called interest. So the interest is then 77,397.60 cents. And there you have it. This is the amount of interest that you are actually paying on this loan. And that's how you do that example, grade 12s.